today we'll be looking at integration by parts using the LIPTE method, or more commonly known as the tabular method. So here we want to distribute this square inside to our 3 and our x. So we'd get integration 3 2 over a x squared. So the power of 2 gets multiplied by the power of 1 over a, and it gets multiplied to the power of 1 that x has. So we get this times e to the 5x dx. So now let's recognize our constants here. Our constant is this variable because it doesn't contain an x. So we're going to go ahead and take it outside. 3, 2 over a, integration x squared e to the 5x dx. So here we have two terms of x, and they're being multiplied to one another. So the way that we approach this is we would do integration by parts, but that usually takes long. So instead we're going to do a shortcut, which is the LIPTE method or the tabular method. They're both the same. In terms of LIPTE, the way that it's called what it's called is because it gives us an order. L stands for natural log of x. I stands for arc tangent of x, or any arc trig. P stands for x. T stands for sine, or cosine, again, just any trig that follows that form, and E stands for e to the x. So this tells us the order and how we're going to put the variables that we have into the table that we're about to make. So the table has a part of it that's derivative and the other part that's integration. So we're going to be taking the derivative and integration of one of these two, depending on what order they have. The one that comes first, looking at it this way, in the LIPTE, which in this case is x comes before e to the x, that lets us know that we're going to put x first in this chart. So we're going to put x squared first, and then we're going to integrate e to the 5x. Okay, so we want to take the derivative here as many times as we need until we get to 0. So we take the derivative of x squared once, we get 2x to the power of 1. If we take the derivative of it again, we get 2, and we take the derivative one more time, we get 0, right? So now we're going to take the integration of e to the 5x, and we can do this on this side if need be. So e to the 5x dx. So we do u substitution of 5x. We take the derivative of that, which is du equals 5 dx. We'd move the 5 over, so we get 1 over 5 du is equal to dx. And we plug everything back in, so we get integration e to the u du over 5. And the integration of e to the u is just e to the u. So we'd get this like that, right? So this is what we're going to put here. Take the integration once. Now, if we take the integration of this again, it's the same thing. The only difference is that now we're going to have an extra 1 over 5. So 1 over 5 times 1 over 5, we get 1 over 25 e to the 5x. 1 over 25 times 1 over 5, we get 1 over 125 e to the 5x. So if you continue taking the integration, you're basically just multiplying everything by 1 over 5 each time. Okay. Now we have signs. So the first one is plus, second one is minus, plus, minus. Now the next thing that we want to do here is we're going to go ahead and multiply the diagonals. So we're going to take this, we're going to multiply by this. We're going to take this, multiply by this. We're going to take this, and we're going to multiply it by this. Okay, so let's go ahead and multiply them. So we have x squared over 5 e to the 5x minus 2x over 25 e to the 5x plus 2 over 125 e to the 5x. Now here, this isn't the final answer just yet, because if we remember, we still have this constant that we didn't apply in here. And we're not supposed to apply it in here. If we want to make it more simple, we don't have to apply it. So what we do with this is we take what we got from the table, and we're going to multiply it all by the constant that we had in the beginning, which is 3 to the power of 2a plus c. And that's going to be the answer to this integration. And this is how we approach a problem like this.